All right, section 7.1 deals with this concept called dilations. So a dilation is going to be a transformation about a center where we're going to have a scale factor. Okay, so you're going to have a scale factor of n, and n has to be greater than 0. And it has the following bullet point properties. Really, like the main ones we want to pay attention to here are a dilation is either going to make the preimage bigger or smaller. So we're either going to enlarge it or we're going to reduce it when we come up with our new image. If we are going to enlarge the image, our scale factor, or n, is going to be greater than 1. So we take our original image and multiply it by a number greater than 1. It would make the image bigger. If it is between 0 and 1, we're going to reduce it. So you're going to take an object that was initially big, and then we're going to make it smaller. So we have a bunch of examples that look at this concept of dilations today. So first off, I'm going to look at example 2. In example 2, they give us two rectangles here. They give us an image, A prime, B prime, C prime, D prime, and then they give us the pre-image, A, B, C, D. And they tell us that it was enlarged from point P, which we'll get into a little bit what that actually means. But for this first one, what we want to do is just compare the angles and compare the side lengths of our two images, so the image and the pre. When I look at each of these, okay, we have a rectangle. And you should remember from elementary school that when we deal with a rectangle, your angles are all going to be 90 degrees all the way around. Okay, so that is true for both the image and the pre-image. Okay, so all angles are 90 degrees. And you will find it doesn't matter what object we're dealing with, when we dilate something, the angles in the object are not going to change. So if I start off with 90-degree angles, we're going to have 90-degree angles in the image. If for a certain object it has a 60-degree angle, when we go ahead and dilate it, it's still going to have a 60-degree angle at that location. So regardless of what we do dilation-wise, you are going to have the same angles in the new image. The thing that really is going to change though is the side lengths. So looking at our pre-image, we have AB has a side length of 1, 2, 3. BC has a side length of 1, 2. CD is going to have a side length of 3. And then DA has a side length of 2. Okay, so those are all of the original lengths that we're dealing with. Now in our image, after we multiply by a scale factor, it's obvious that our side lengths are going to change. Okay, so now when I look at A prime, B prime, when I count up the side, instead of having 3, I'm now at 1, 2, 3, 4, 5, 6, 7, 8, 9. B prime, C prime went from 2 to 1, 2, 3, 4, 5, 6. C prime, D prime is now 9. And then D prime, A prime is 6. Okay, so we had our original, we had our pre-image in the purple, and then our new image is in the blue. And then to compare these side lengths, what we're going to want to do is find the ratio. Okay, and we're always going to go from the image to the pre-image. Okay, so in this case, we would have, I'm trying to think how I want to do this. We got A prime, B prime to AB equals 9 over 3. B prime, C prime to BC equals 6 over 2. C prime D prime to CD is 9 over 3. And then D prime A prime over DA is 6 to 2. So when you look at all 4 of these, okay, if I go ahead and divide each of those fractions, we're going to end up with each of them equaling 3. All right, and whatever that ratio ends up equaling, that is going to be our scale factor n. So for this one, we have a scale factor of 3. Okay, that's the big takeaway on that example 2. Going to example 3, instead of having a rectangle, which is nice because all the angles are 90, we now have a quadrilateral. You look at it, you have a center in the middle. Okay, we have our pre-image JKLM. And then we are multiplying this by a value n, which is making it bigger. So the first thing I'm going to notice here is that I have an enlargement going on. Okay, the reason we can tell it's an enlargement is because I started with a small quadrilateral, and then when I multiply it by something, like it's getting bigger. Okay, it's getting stretched out. So since we have an enlargement, we know right away our n value has to be greater than 1. And then from here, to find the scale factor, you're going to do the same thing we did before. Okay, you're going to ratio the 2 sides. And the pre-image goes down below, image up top. So I want L prime, K prime to LK. So we're going to have 18 over 12. And then you're not going to want to leave that as 18/12, so you want to go ahead and actually simplify that. So both 18 and 12 can be divided by, 3? So that would give me 6 fourths. Sorry, I can take it even further. We can divide it by 6. Top and bottom by 6. So when I do that, 18 divided by 6 is 3. 12 divided by 6 is 2. And that is my scale factor. So what they did is they took each of the values for my pre-image and multiplied them by 3/2.